What's up, guys? Chris here. The Clearpath motors came in today, finally, after a fiasco with UPS not delivering it, making a quote-unquote attempt that they never actually made. Anyways, they're here. This is the tuning software that I'm messing around with, and this is the novel of directions. This is all directions for those motors. It's insane. It's a lot of pages. Clearly, it's over 200 pages. So the manual is extensive, to put it mildly. So I'm doing the initial setup, which I'm just following the directions. I'll do it on all three. And I got 2 of the 4 couplings I ordered. I don't know why the second 2 are taking so long. I'm going to take a look and see when they're supposed to come, because it kind of really sucks that they haven't come yet, because I have 2 and not the third. And now, feeling how rigid these are so rigid when they're powered that they this could have held the Z-axis like a stepper. I should have bought a 4th, but I mean, the Z-axis, I'm kind of okay with it like that. It's not a big deal. I did get a 72 volt power supply, because to get full power out of them, it's recommended. But these are such a tremendous amount more power than any stepper or the other servos. These things are capable of over 700 ounce-inch or 5.7 Newton meters of torque. So it's like warns you before you start and before you enable it, because you can enable it just through USB. They're pretty sophisticated motors. I mean, you can just literally enable them through USB. Now expected by March 17th. That's today. So I'm going to check in the mailbox and see if these are up there, but I don't think they are, because, oh no, this was coming from Amazon. It did not come today. Okay, I have to just go and reorder them, because these aren't coming. 6 to 10 millimeter arrives Thursday. This is crazy. I'm just gonna bore one of the other ones out, or maybe I'll use one of the other couplings I have, and I'll machine a spacer. This is insane. I can't believe this is you know what? Let me see if there's any other stuff like it. Where is there more stuff like it? Hold on. 6 millimeter to 10 millimeter rigid coupling. Yeah, that's literally the first one that comes up. There's another one here. This one's stainless steel. Oh, the other one, mine's stainless steel too. Oh, my MacBook, I got an adapter for this. My MacBook, it's resetting. I saved all my information, and I made a boot disk and all that. I put a solid state hard drive, an NVMe solid state hard drive like these. Like these little hard drives. And this is what Apple puts in them, like this. Of course, proprietary. What do you know? Shocked. But they make an adapter for $10. I know this is off topic, but just because I'm sitting here and it's almost done, they make this little adapter. I got 2 of them because my fiance also has another MacBook, and it's the same model. It's this 1608, I believe. So they make this little adapter, and I bought these on Amazon for $10. And the adapter looks just like this, you know, goes in the same slot as that, and then this goes into it. And then one of these goes into it. And I got these 2 terabyte for, I mean, this at a 1 terabyte one of this that would fit the Apple, that's an actual hard drive like that, would be $250 for 1 terabyte. I got 2 terabyte NVMe hard drives for $160. So one for each of us at 2 terabytes. And then these for another $20. So $180, I got 2 terabytes for each computer. So less than half the price and 4 times the storage. So Apple is like such a total ripoff. Not that that's any breaking news, but anyways, back to the CNC machine and the servos. So I'm very excited to get these on the machine. I haven't done any. I've done the, I got the power wires done and the Molex, just a testing cable. I got Molex connectors. They're Molex Mini Junior, and those are they're kind of expensive connectors for what they are. But I think it's because it is pretty cool because they come with a removal tool, and it works actually really well. It's not like other connectors that can be removed. You just like they're cylindrical, so on both sides. One is female, one's male, but they're both cylindrical, and you put this little probe in there, and it has a spring action in it, and it just pops right out, and it can go right back in, and it works over and over again. It'll work, so it's pretty cool. But I've got this set to go 2,000 RPMs. Let's see, it's over there in the vise. Let's see if I can zoom in where you can see it. There it is. See, it's sticking out of the vise in a motor mount. So there's a coupling on it. I'm gonna turn it on at 2,000 RPM in one direction and then the other, just so you guys can see. I'm just controlling it with a USB. So that's one direction, and then the other. And I'm at 2,000 RPM right now. Oh yeah, see, it's counting. Wow, it's got a serious amount of pulses per revolution on the encoder. I'm very eager to get these onto the machine, onto the CNC. I really am dying to see how it operates with these. I mean, I know I just put servos on it, but these are like the cream of the crop servos, and I have to redo the whole electrical enclosure again, because I have this power supply that's in there is not going to do me any good. It's 48 volts. I need 72 volts, and I already have a beefy buck converter that can take the 72 volts and whatever, and reduce it to 36 for the control board. If I'm going to use that control board for right now. This is the alternative if at some point I decide to go to a Mach 3 control board. These control boards are very inexpensive. This was like $25 or $30 with the jog remote. I think it was $30 with the jog remote and the CD. So it was pretty good price. So I got one. I actually got this as a way to test the motors, and I haven't really messed with it yet, but I'm going to, and I may try to use Mach 3 at some point just for the additional freedom. So all the limitations of cut controller will be gone, like the 100 inch per minute limitation. And then also, I did get a 24,000 RPM 2.2 kilovolt water-cooled motor. I don't know if I'm going to actually use it yet, because I really like the servo. I like the big 220-volt servo, AC servo. But I don't know. I have to do a little more research. I saw it online, and I said, you know what, screw it, because I have so many motors already, and I don't have any other spindle motor for this. I have a couple other servos, but they're not as big as I would need or want for the spindle motor. I have, like, right here is a 1,000-watt one, a 1,000-watt NEMA 34 220-volt AC servo, and then I have a NEMA 23 AC servo, and another NEMA 34 AC servo that's 750 watts. The NEMA 23 is actually a really powerful one. It's a long one. Anyways, I don't, if I had more NEMA 23 AC servos, I might use those on this, but now that I got these Clearpath, these are more expensive than the freaking AC servos with the drives. These are, I mean, it's when you think about one motor, $300, because I got the shaft seal on it, and to make it more waterproof, and I didn't get the bolts on the back instead of the connection terminals, but I don't need it to be 100% waterproof like IP69 or whatever. It's IP53 anyways. The USB port gets covered. The Molex connectors are watertight. I'm going to make mine watertight. I didn't buy any of theirs. I'm going to make mine watertight. I have the connections, and I have all. I actually recently got all Nipex crimpers and like the ferrule crimper and even the crimper for these fittings, and a bunch of their electrical tools, and they were really expensive, but honestly they're very well worth it. I mean, they're German made tools, and I mean, if you guys know anything about German made stuff, it's really top of the line. and not so much for cars. Their cars are beautiful, but they're a brutal pain in the neck to work on. But anyways, also I did finish the water cooling for the bandsaw, but I need to extend the tray because it is getting a little bit of water coming back around the saw, and I didn't want to go too far out because I didn't want to get in the way of the clamp. But I'm gonna have to go further back than I did because there's dripping water right there. But I made a first stage of the drain, and that's where all the chips go, and then it overflows out of a PVC pipe into the main stage, the second stage, which is the larger stage of the coolant reservoir, and the chips and everything will go in there when it's making long cuts. I just do need to extend the tray, which I'm going to probably do that tonight too. I'm going to do that, and I'm going to get these motors put in, at least the two, probably all three somehow, because I'm just driven to do that. And now that I decided to do it, I'm going to do it. So I will keep you guys posted. I'm going to finish doing the startup tuning on the other two motors, finish configuring where the wires are, what pins are for what. Obviously I have positive and negative for power figured out. I need to know the rest, and I'm going to figure that all out, and then I'll be back with you guys when I get all those wire connections started, and we'll take it from there. I'll show you the rest, and I'll show you the machine moving with the new Clearpath servos. And then I'm going to be doing, I'm already starting to machine that's what initiated the water cooling on the flood cooling on the bandsaw. I'm already starting to machine the cast iron, the gray cast iron I got for the Z-axis gantry risers. So I'm starting to machine it down to, I'm starting to cut it down to machining size, which is 4 by 5 by 2.5. And it's going to wind up being 3.88 by 4. I forget exactly, and then 2.25 inches high. I'm going to go 2 1/4, and I already got the number 12.9, grade 12.9. It's in metric, but it's still like higher than grade 8. Grade 10.9 in metric is grade 8 in American. So grade 12.9 is a really strong bolt. I got 70 millimeter M8 125, which is what the bolts that are in there now are, and you know, they're long enough to go through the spacer, through the lift, and that extra weight is gonna make this torque really, especially on the y-axis, but also they're generally smaller on the y-axis, the motors, but to get these motors in a smaller size, it's like such an insignificant difference. It's like $10 or $20. So you really don't save much by getting smaller motors. So I said, you know what, I'll just get all three the same size. And they're not as long, measuring as long, like I'll show you. They're not nearly as long measured so as the easy servos. So this is approximately, it's just a hair longer than the shorter motor. But this is this is one of the higher power ones. They have them like really short. So this is the smaller of the two easy servos that I have on the two on the y-axis. But this will fit on the y-axis like this. It's only another inch or so. And then I'm probably going to put a fan on the back somehow. I'm going to mount a fan on the back because apparently mounting a fan on the back adds a ton of torque to these by keeping them that cool. So, and just, dude, just the quality, you see the shaft seal, so it's watertight, but just the quality of these, when you hold them in your hand, the way that they're made, these things are made so solid. These things are made really, really well. They're made really, really well. They are really made really well. I'm very impressed with the quality. And I mean, for over $1,000, I didn't order any wires or anything, but you literally get this motor in the box. That's it, and a bunch of foam. That you get this motor in the box. That's it. The end. You don't get a key for the shaft. You don't get anything else. Just the motors. But this is by far the most high quality motor I've held in my hand for a NEMA 23 motor ever, and that includes the AC servos. This is a really high quality built motor. So I'm very eager to see these operating on the MR1, which really isn't going to be much of an MR1 left of it. I'm probably going to get an aftermarket touch probe as well because their V2 touch probe did not work for me. I actually got the upgrade kit and then I got a full V2 touch probe. Neither one of them worked. The V2 that I ordered, the whole thing was getting stuck. The kit that I ordered worked all the way until like through a couple operations, and then it just smashed the whole stylus. And I ended up just going back to my original one and sending all that stuff back because I was like, dude, this needs to be refined. It smashed my stylus. You know, I took the stylus off the other one to replace it, so you don't have to send me nothing. But like, and then the second one's getting stuck, and it's telling me it's triggered before it's even touched anything. I'm calling it quits. I'm going back to my original one. But I'm going to try to find a higher precision one and use it. And I don't know if any other third-party touch probes are going to work with cut control. So between the limitation on speed, especially now with these motors and stuff like that, that's what's making me consider Mach 1, Mach 3. So we'll see how that goes. I may end up going to Mach 3, I may not. I'm probably at the very least going to test it. But right now, I'm just going to be concerned with getting these motors installed, getting them wired, getting the new power supply into the housing, taking the 48 volt out, and the other buck converter I have to take out as well because it won't be nearly powerful enough. I'll blow it by hooking it up to this power supply. So the one that I have here, the big one with the big heat sink and the fan, that one's going to have to go in there, and that's going to be that. So I'll bring you guys back in a little bit. I'll show you the bandsaw water cooling setup. I did do the copper pipe that goes over it and is split in the middle, and it goes right over the blade. Which is probably why I'm bringing a little water around, but that's all right. I'll just extend it. I have some metal left. So I'll probably do that real quick, and then I'll bring you guys back because I just want to get that squared away so I can start cutting the cast iron for the Z-axis. But I'm going to do this before that. I'll probably do that and then put these in, and I'll bring you guys back to see the water cooling on the bandsaw and the motors going in, and the motor's working after that, and then I'll go doing my my Z-axis gantry lift. But I have to tune these other ones as well, so that was just for reference. The other one, I'm not actually doing anything with it. But this shaft is so solid, dude. I can't move it at all. Not at all. It's stronger than the steppers. And the other servos, they were strong, but like you could move it a little bit and it would fight its way back, and it wouldn't lose any steps. It would come right back. But this, you can't move. You can't move that at all. You're not moving that. It's got a lot of rigidity. So anyways, I'm gonna call it here, and I'll bring you guys back when I'm in the shop. Once I bring all this stuff back, the new power supply, I got some DIN rail hardware that I'm going to mount to split. I'm going to do the 72 volt into a 3 to 15, and I'm only gonna need 3 of them for the 3 motors. But well, that's 3, 6, 9 out of 15. But I'm sure I'll find a use for the others or not. We'll see. But I'm very eager to see these motors on that machine. So let me get back to it so I can get over there. All right, later. What's going on, guys? I wish I could say I got more done. I actually did get a lot done. I had to redo the whole electronics panel, and I did do that. And only the first motor is in, and it's doing an auto tuning process right now. These motors are pretty incredibly sophisticated compared to pretty much all the other motors that I've dealt with. So here's the electronics enclosure so far. I mean, it's not so far, it's pretty much done. So that's the new power supply, 1500 watt, 72 volt. And this is the bigger buck converter that I'm using. And that's the standard Langmuir servo driver and the large stepper driver for the Z-axis, and then the cable raceways that I put in. And I kept everything all nice and neat. And then here's the first Clearpath installed, doing its tuning. So I'm gonna seal up. That's the USB coming out towards me. It's got a USB plug in the back, and that's how it communicates with the computer, which is pretty cool. But it's just moving it on its own right now. It's only going to move in one direction because the 2 Y-axis are not on. But honestly, if I had known how rigid these motors are, I probably would have gotten a 4th one for the Z-axis, because that's the only one that makes any noise, and these things have a crazy amount of power. So when I'm starting to do the auto tuning, it's giving you a warning that they can create 700 and something. It's like 5.6 Newton meters they can create of force, of torque. It's pretty incredible for a small motor like that. It's pretty astounding. But it says it's going to make some fast and violent moves, or I don't remember if it said violent, but it said something, loud noises and stuff like that are normal. So I don't know. This is my first time seeing it do an auto tune. It's my first time seeing using one of these motors. So, but there's no auto tuning process like that. I mean, you can manually tune everything yourself on the other servos, which is what I did. But you have to do that. You have to manually tune it yourself. So, it's. And to find exactly what is going to be the best parameters for the motor is not all that easy a lot of times. I mean, in my experience. So that's it's nice that it does that for you, and they have a way that it's set up that it's going to find its own best parameters, which is pretty cool. So here's the bandsaw. So I had already done this, and I ended it here, obviously, and I ended up having to extend it because I had water dripping from over here, coming around on the saw blade. But so this is the way the guy did it on the video that I saw also. This, he not exactly, but very close. He did the copper, the bent copper, like soft copper that you can bend with a pipe bender, going over the blade, directly over the blade. And that's what I did, and I routed the hose right there, and it goes into something I did that he didn't do. Is I made a first stage drain where that's where all the chips will go when I'm cutting. So all the chips that go through here, which I have to grind down that drain, because I actually had just a hole going into that, but it wasn't close enough, and it was starting to splash underneath. So that's why there's water on the ground, but it won't be getting on the ground when I'm using it now. I mean, that's what all that extra stuff was about. I had to make a more thorough weld to the machine so that it didn't drip in between it, and the welds in the metal were good. And this is 16 gauge, so it's pretty thick sheet steel. But anyways, it'll be nice to be able to cut these pieces. That's the rest of the cast iron, that big block for the Z-axis risers. And this is the part that I already started machining, and you can see my mill is a mess because this stuff is dirty as hell. I mean, the cast iron just doesn't machine well. I mean, it does, like, it machines fairly easily, as far as, I guess, if that's what I'm thinking about machining well, it does machine pretty well, but it makes a mess. So I'm looking forward to getting it in the CNC and in the enclosure. So let these motors do the machining for the reason that I got them. Well, one of the reasons I got them because I was intrigued by them more than anything. But you know, the fact that the gantry is going to be a lot heavier with the cast iron lifts was just another excuse. It's just being honest. So these motors actually, they home themselves too. So, I mean, talk about sensorless homing. It knows exactly how far it can go in each direction and like exactly how many rotations. And it makes me tell it. You know, like I had to move it all the way in one direction, all the way in another direction, and then it could start the auto tuning. And it tells you it did like 116 point something rotations, and that's the maximum area. It's not really all that loud, if that's what they were talking about. So, here, let me shut this fan off. Yep, that'll help. And put this back up here. And then I'm just gonna let this thing do its tuning, and then I'm gonna have to call it quits on this, because this has been. I haven't recorded much because there wasn't really much to record. I was, you know, down on the ground trying to organize that electronics enclosure and, you know, rerouting wires, and I put that DIN rail mount with the splitter for all the power to just go out of, you know, have one main 14 gauge stranded wire coming out and going splitting, you know, for one for positive, negative, and ground, and then splitting into 5 of each, and then all those go to everything else. The only other thing I hooked up to one of the other two main outputs from the power supply was the buck converter. And why, don't ask me. I don't know. I don't know why. I could have run that right there too. I had the wire run already from the other buck converter that I had in there before this. So that's why I just used the same one. Come on, what is this thing doing? I don't know why my surface is running so slow. Oh, it's done. Oh, no, it's not. Is it going again? Oh, no. No, it's done. Do I need to run it again? Click on the begin the auto tuning process. Pause allows you to stop motion and then continue where you left off. To stop the auto tuning process and disable, click the red escape button or press escape on your keyboard. Clicking next will bring you to, oh, there we go. Now it actually did. Oh, I lost communication with it. Seemed like this computer's acting up. Oh, well, the battery's almost dead. That's probably why. I should be doing it on here. I got this freaking big ass computer right here. I don't know why I'm not using it. Downloads. They don't make it all that easy to find this software. I found it on multiple computers already. I don't know why it's I don't remember how I found it or what I did, but this is I thought it was right here. No, that's drawing, and then CMP, and then user manual. Where is the tuning software? Anyway, so the tuning software is actually, it's actually got a lot to it. It's actually pretty it's pretty cool. It's got some some good stuff in it. No, oh, okay. Integrated servo motor. I actually looked into. I've been looking into and kind of considering getting a large NEMA 56 stepper motor. I mean servo motor to replace the 3 horsepower AC spindle motor on my lathe, because you know DC motors are much more efficient, and they're much quieter, they're much smoother, they just run so much better, especially these motors in particular. That motor, just testing it for a minute, I mean it's completely quiet, and it just like instantly it's incredibly well made. It's I mean there's a reason they're so expensive, obviously. All downloads. Why is this all downloads and I don't see it? Oh, step in direction right here. No, that's a movie. That's a video. Quadrature, step in direction. Where the hell did I download this? Oh my God. I don't know why I can't find this. Downloads. Okay, Clearpath, SD. Yep, it's this body. Oh, here we go. This is where I'm not even, what a dumbass. Okay, open that. I got it. It's not doing anything right now, but it's going to be, because this thing is about to die. That's why it was acting up. The battery's almost dead. So I'm gonna give it a break, and I'll plug it into the big computer. I probably should have just done that in the first place, because this one's plugged into an Ethernet cable. My Wi-Fi, even though I have several access points throughout the building, this is kind of like a spot in between two access points. I actually, because of that, and because of like being frustrated with it today and tonight, I ordered another access point to put. I think I have like 5 or 6 now in here. But this one should get the last spot, which is my workshop, or you know, this area of the building. I accept. I got 2. I got one for outside and one more for inside. Next, install. Because I have like I have a couple of. Most of the cameras are hardwired, but I have a couple of ring cameras and ring doorbells. But yeah, I'm really tired. I'm overworked and overtired right now. I gotta get home and get some rest. But I'm very excited about this. I probably don't seem like it right now, but I'm very excited. These motors are impressive, and I'm very eager and excited to get them all installed and see how this thing does with at least the X and Y axis on these motors. Okay, let's plug this in. So this is what the tuning software looks like, and you can see. So yes, auto tune the motor and connected mechanical system. This tunes the motor to the mechanical and yes. Okay. Next. Okay. Yes. Where is this? Where it says it? Clearpath motors generate a substantial amount of power for their size. Do not continue this process unless you are qualified to evaluate whether your mechanics are built and sized properly, and you have done so. Blah 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 blah. And improperly used or upon malfunction, Clearpath can cause significant damage, personal injury, or death. This motor has a peak torque capability of 717 ounce-inches and 5.06 newton meters. That's pretty substantial. Max velocity is 1030. No, I'm going to do 1500 RPM. Not that I'm ever going to need it to go that fast, but yes, it's limited rotation. I want to move the mechanics powered. Okay, so it has you move all the way to one extreme and then to the other. And as soon as you hit your control key, it's enabled, and then you can move it. And that's going that way. Okay. All right, I'm going to turn the speed down a little bit. That's it. That's all the way. Okay. The following behavior is normal. High-pitched squeals, low-pitched grunts, fast, abrupt moves that ring, slow, uneven-looking moves, buzzing, pauses of unequal length up to 20 seconds, short moves and long moves up to 90% of the auto-tune area you should have set. Okay, well, whatever that means. All right, well, it's doing its auto-tune. I'm wondering how am I'm probably going to have to reach out to them because I don't know how I'm going to tune the two back motors individually when they're both moving one axis. Yeah, I mean, it seems like I mean, not it seems like, you have to do this with them not installed on anything to initialize them, and then you have to do this again with them on your mechanical system, which happens to be the MR1 for me. Oh, I have to hit run. And now that I am doing that with this motor, I'm wondering what am I going to do with the other two when it has to be. I mean, don't get me wrong, they can each move that axis individually, because I've had that happen without even realizing it. So one motor can move both of those ball screws and force the other motor. I mean, it's not really fighting very hard when it's not on, but or when it's not functioning. I wouldn't think. Well, that's funny. It's kind of just like going back and forth. Probably getting a feel for the weight. The x-axis should be consistent. I did get a high-speed spindle. I haven't decided whether or not I'm going to use it. And yes, I bought it, and I don't even know if I'm going to use it or not. Because there's a lot to be said for being able to go, over 10 and even over 20,000 RPM. This thing goes 24,000 RPM. But there's also even more to be said, in my opinion, for not quite as fast, but a lot of torque, like this servo motor has. So that's why I haven't changed it so far. And the auto tool changer, that's not going to really benefit me enough. I don't mind changing the tool. It's not very often that I have machining processes that have so many different operations that I am like troubled by changing the tool 2 or 3 times. So I'm not going to bother with that. It's very expensive too. I think the money's way better spent like this, in my opinion. I would rather get these motors and have the motion system have a lot more oomph and be a lot more capable than to have an auto changing tool head. I mean, don't get me wrong, it's a bell or whistle, whatever, but and it's definitely a perk. It's definitely a quality of life or whatever you want to call it, but it's not on my top priority list. I mean, that could change with a whim, but I don't see it happening right now. But all the stuff that I really wanted to do here, I got done on this machine. I mean, obviously, I got it done 3 times with the motors, but the cooling system, the cable management, the cleaning up the electronics enclosure. So what I am going to do is these servo motors. They sell a thing that goes on the back of it with a fan, and they say that it actually increases the power of them by keeping them cool, which makes sense because even like small steppers in 3D printers, you keep the drivers cool and the stepper motors themselves cool, and they don't skip steps, or they skip steps less. Or it's harder to get them to skip steps, and I mean, all that's, they have more power. They can produce more before they give up. So, you know, keeping them from getting too hot is obviously a good idea. So I have three fans that I brought out, and they actually line right up. There's holes in the back. I don't know if you guys can tell, but you know how all these fins stick out like spikes, but there's 4 holes in the back, and they're not threaded. They're a little big for M3, but an M4, I could tap an M4 into it, and it would be very easy. So, it's aluminum, so it's not going to be hard to thread. So I think I'm probably going to tap that M4 and then put the 4 M4 screws. This is a, what is this, a 30-30? I think this is a 30-30. Let me measure it real quick. I want to say this is a 30 millimeter by 30 millimeter by 10, or yeah, by 10, I think. Hold on. It's a, oh no, it's 40. Okay, so 40 by 40 by 10. It's a 40 millimeter, 40 millimeter, 10 millimeter. So if you guys ever are interested in doing this, and you want to put, I suggest putting fans on it, because after finding out what I did, that it actually makes them produce more power, and I mean, it's substantial. And the voltage is also something that they continue to reiterate multiple times when you're reading through the literature, when you're watching online, whatever your research you're doing. They continue to reiterate that the voltage should be, you know, as close to 75 as you can. That it's going to make a big difference in torque if you use like 48 volts or 60 volts or whatever. So that's why I got the 72 volt power supply, and it's their power supply is 350 watts. That power supply is 1500 watts. So, and it was half the price. But and it, you know, it does have cooling fans in it, and it seems like it's well made. We'll see how long it lasts, but I mean, it seems to be doing good. It's giving me exactly 72.7 volts. I want to say 72.7. I measured. But anyways, I don't think this is going to take 2 minutes. It's going kind of slow. It's obviously going to do its thing. Sorry about that, air compressor. So I'm probably going to head out of here and catch back up with you guys when I get back later on. It's already today, so yeah, later on. I'll probably just let this keep going. I mean, I would like it to finish and shut this down before I leave, but it's not going too fast. I'm just gonna leave all my stuff out because I got so much more to do in here. Yeah, well, it's 42%. It's not too bad. Yeah, it's literally just like weighing. It's like seeing how much force it takes to move the head, which is cool. I think it's really cool. It's something that you have to guess by looking at. If you're tuning it manually, you have to guess these parameters by looking at the oscilloscope on the tuning software. So that's obviously not going to be as accurate as obviously they know what parameters and what you know, what resistance it's getting by what it's doing right now in different motion systems, different mechanical systems. It's getting different amounts of resistance based on the weight and what it's got to move and all that. So the fact that it does all that on its own, I think, is pretty remarkable. Obviously, you're paying a premium because there's a lot of time and energy and effort that went into developing these. 51%. Okay, I'm gonna let it finish, and then I'll get going after that. I think I'm gonna actually email them too and ask him what I should do about tuning the two motors that are going on one axis. The representative from there was actually incredibly knowledgeable and helpful. It's another thing, they have good employees, you know, that's not cheap. He was knowledgeable, like he wanted to know what kind of ball screw, how much my current motor's torque was, to see like what I actually needed, and he was very thorough, which I found out this is a C7 ball screw, and I did have the amount of thrust. They didn't have the amount of torque. They had the thrust rating of the original motors, which it doesn't matter now. I've changed them, you know, multiple times before this. And all the other motors I put in had more capabilities than those, and the driver, you know, when it was a separate driver. When it was or is. Yeah, so it is doing some banging. All right, guys, I'm gonna wrap it up. So hopefully you guys are getting some good ideas, getting some good insight to on stuff to do to your MR1, either when you get around to it or when you get your MR1. There's been some people that are looking into it that have commented on videos in the past that I've done on the CNC, and you know, I mean, it's I don't think you can find another CNC machine that's even close to that capable for that price. I mean, I think this starts at, now, it was, when I bought it, it was, it started at 5,000, and I, with the enclosure, the flood coolant, all the other stuff that I got, the vices, and all the other bells and whistles that I added onto it, it was like, it was closer to 10. But even for 10, you can't get anything else for 10. Not that can cut steel and titanium. That's got a 4 foot by 4 foot enclosure. You just can't get anything that big and rigid for that price. You can't. I mean, I have looked. I mean, obviously when I bought this, I was looking. So I didn't, and even when I bought the mill, I was looking through that type of stuff again. And when I bought the lathe, and when I bought all the other machine equipment, I was looking through machine equipment, and you know, something catches my eye. But I've only seen like benchtop CNC machines, and they're capable of milling aluminum. They're not gonna mill steel and cast iron and titanium. It's just not gonna happen. It's not it's not even that the motor's not capable enough. It's that there's no rigidity. They're not heavy and stable. But anyways, hopefully this whole journey of mine with this MR1 has given you guys some ideas. I do have that other control board for Mach 3. I haven't decided whether or not to pursue using it. I'm probably gonna explore it a little bit more before I make a decision, because I don't know enough about it to say I'd be making a decent educated guess or decent informed decision on whether or not to switch it. But I guess I'll explore it a little more and see if it seems like a good idea. The only thing that's enticing is to eliminate that limitation of how fast you can go, and of a couple of things with cut control. But it's not, they don't limit it a crazy amount. I mean, well, they don't limit it a crazy amount, but they do limit it more than I'd like. So anyways, but I'll bring you guys back later on today. It's the morning already, so I gotta get my ass out of here and go home and get some sleep. But I'll bring you guys back later on today after I get some sleep and have some energy, and I'll show you what else is going on and what else I'm doing when I get the rest of that. I'm gonna try to get a response to whether or not to how I should tune those two motors that are on the same axis before I do it. Hopefully they'll get back to me today. I mean, if they don't, I'll just figure it out, but I'm sure they probably will. But either way, I'll see you guys later on, or in 5 seconds for you. I always say that like it's going to be later on, but you guys are going to literally, in 2 seconds, the page is going to turn and it's going to be, you know, however long from now. Anyways, have a good night, guys. Hey guys, what's going on? I know it's probably like deja vu. I got the CNC machine banging itself around doing the auto tune. So I got a hold of Technic. I got to tell you, their customer service is out of this world. I called. I didn't get a hold of the guy I was looking for, who it turns out isn't a sales rep. He's an engineer, which makes sense because he really was incredibly knowledgeable, and now it makes sense why. But I had emailed back to make sure that he got credit for the sale because I had bought the motors, and I didn't talk to him before I did. So, but apparently it was unnecessary because he's an engineer. Anyways, I did end up installing fans on the back. These are 40 millimeter fans, and the holes are too big for M3, but you just tap it M4. Use a bottoming tap. You got to use a bottoming tap because otherwise you won't get far enough in, unless you use very short screws. But I wanted it to be secure. But the holes are already there for you. You don't have to drill anything. You just tap it. So I'm retuning this motor because what he said is, so first of all, my first question was about the enable switch, the enable pin. I don't have an enable pin. The MR1 doesn't have an enable pin. It uses step and direction because it wasn't a problem with the other servos or with the other servos. You just didn't hook up the enable pin and it still worked, or you could use the same positive. These know the difference and they want that extra enable. You know, they're not going to be enabled. They're not going to start moving unless you have it. So what I did is I put an e-stop switch of my own right on the front of the machine, not on the electrical box that's going to be all the way in the back of the machine that you're never going to be able to reach or get to it when you need it. But I'll show you. I put it right here, so you see it right there on the front on the leg. So that was from my lathe or from, I don't know, from something else that I had taken it out, and I went and grabbed it and I put that as an immediate disconnect for both X and Y axis. I might even jump Z through it just to have an e-stop for all the motion, I might jump all the power through it, so I have an e-stop for the whole machine that I can actually get to. Anyways, the point is that I had to run a 24-volt power supply, and I ran it by him. My suggestion was, what if I used a MOSFET or a solid-state relay with the trigger signal as the pulse or direction, and that would enable. But honestly, he was right. You want it enabled before that, before it starts sending pulses or it's not moving. So that's true. Obviously, I didn't think of that. I mean, I kind of did, but I thought it might work anyway because it's at the same time simultaneous. But it's just, anyways. So what he said I could do, and what I propose to do is, I mean, alternatively, long-term, potentially can change the whole control board, which I might end up having to do. I might end up wanting to do. That might be one more incentive to make me want to do that. But for now, I just put a small DIN rail 24-volt power supply, which is really, I mean, it doesn't need hardly any amperage because it's actually, and it was good. I had to do a bunch more wiring, so it wasn't great, but I already did it for the X-axis. I'm going to do the two Y-axis motors. The wires are already sitting in there. But I added the 24-volt power supply right there, the gray power supply next to the big one, and that's going to the emergency switch, and then it also gave me a way to wire the fans. So I just did 4-wire instead of 2, and I have 2 of the 4 wires going to the motor for the enable, positive and negative, and then I have the other 2 going to the fan. So the fans all have power now, so I can keep the motors cool and get the extra power out of them, and the enable is satisfied. So that was one thing I had to do some way somehow for it to work. So that's how I'm doing it for right now. Long term, I may actually, more seriously consider switching to. He suggested a few different motion controllers for like Acorn and Masso. I'm looking at a couple different ones. The one that I have that's for the Mach 3 board is it might be short on terminals for me, like inputs and outputs. I'm not sure if it has enough. I don't see why it wouldn't be all right. But I saw a couple of setups. They're like $400 or $300, 300 to 400. But they come with the jog pendant and then a whole monitor, and it can be an independent system, offline system, which is nice, not to have to, you know, you could put the G code in it as a file and not even have to operate the computer. And then maybe I could take this monster workstation PC out of here and just put a small laptop. Which, I mean, I don't really have anywhere else I need it right now. I have too many computers. But I don't know, I'm just thinking the space. I have a lot of space in here, but I'm obviously using it. This is like 2,000 square feet, and it's completely packed. So I got to take some extra space where I can get it, even if it's just this one workstation, which would still be there with just a laptop on it. So it's really not any much of a space savings. I probably would just leave the computer in here, because if I want to work on Fusion or something when I'm in here, I want something with a lot of processing and graphics power. So anyways, it's almost done. It's at 92, 93%. Once it's done, what he said to do about the tuning, both, because I said I have both of the other two motors going on one axis. How can I tune them one at a time? He said, you don't tune them one at a time. What you do is tune your X, and because you have two motors on Y, and they're you know, they're both the same power as this one, and it is moving more weight, but you have a lot more power. Just give it the X, save your config file for the X, and put it into the Ys, and it should be fine. If not, that they would remotely log in and tune it for me. So I mean, what more could you ask than that? They've been great. They really have. They've been awesome. The guy's name is John, by the way, the engineer, and he's been awesome, and he's really smart, really knowledgeable. And as soon as you talk to him for 5 seconds, you know that he knows what he's doing. You know, he's one of those guys. Like you can tell immediately that he knows exactly what he's doing. So, I mean, the fact that he's an engineer didn't come as a big surprise. But anyways, I'll bring you guys back in a little bit. Right now, what I'm going to do, it's kind of a shame because I spent all this time waterproofing these servo motors, and they were waterproofed. There wasn't even a bit of moisture inside these. Well, the one I cut open so far. So you see that there's the Clearpath. I have to clean up those wires still. But back here, this is what I did to these. If you saw the other video, you would have seen what I had done. Or part of it as I was doing it, but I had used, that's electrical tape, not standard electrical tape. That's outdoor. That's really expensive stuff. It's outdoor electrical tape that adheres to itself only. It doesn't really stick to anything else. So I wrapped that around the base of the driver and right over the dip switches, and let it stick to itself around it. You know, one big layer, like two rows, and then I did 6 mil plastic, and then I went over that all the way up. So I mean, it's like totally watertight. I mean, these I haven't opened yet, obviously, but this one, the one that I took out, was bone dry. And then on the actual wire terminals, I did thermal glue, silicone glue, like you would use on any other electronics to keep the connections in place. So I did that, but that keeps water out too. Silicone is good for that. So I'm going to cut those other ones open and then run those other couple wires, save this configuration file that I'm making right now, and install that on the other two, and I'll be in business. So I'll bring you guys back in a little bit, and I will have this thing running, and then I'm going to start cutting the rest of the cast iron and getting that thing ready to machine. Once this thing's running on its own with the Clearpaths in there. Oh my God, I had this thing moving last night. It moves so fast. The whole housing was shaking. Those motors are crazy powerful. Crazy powerful. Like way more powerful than I even thought, even with all of the stuff I had heard. I'm going to try to show you right now. Must be disabled prior to finishing auto tuning. If you want to move the motor to a different spot, no, I don't need to do that. Okay, disable. Next. while running Clearpath can be manually fine-tuned a moderate amount to suit your preference for audible noise versus shaft stiffness. Open fine-tuning dialog, tuning menu if you want to make fine adjustments to the tuning. No, it's quiet and it's powerful. That's good for me. You can change the motor identity settings at any time. Nope, finish. Okay. Alright, so I'm going to override inputs and do this, and I'll show you just how fast this thing moves. Whoa! I might have just smashed my limit switch. Oh, do I have to restart it? Oh yeah, I have to cut power. So, I don't think that'll do it like this, because I have to cut this power. That very well could have broke the limit switch. See, that's the thing with these. They are so powerful. If you don't have everything in order, like, I mean, I have everything in order, but I have already run auto tune or loaded tuning configuration file for this motor. Yes. Okay. Next. So that is saved, right? Let's see. Okay. Let me save it now so I have it for the other motors. Okay, this is going to go in. I have a file for CNC. Documents. I want to put it on OneDrive so I can get it on all my computers. CNC files. This is going to be X and Y servo config. Okay, now override, and oh wait, that was clockwise or counterclockwise? Nope, wrong way again. Beautiful. Oh, that's perfect. I got to do it again? Are you kidding me? Okay, I need to go clockwise the next time. Let's see. Is it going to let me? There we go. Oh, no wonder. It's going all the way to the end. Why are you doing that? Why is it not only going for a second? Oh yeah, the motor's shut down that time. Yeah, I'm gonna have to restart it. Okay, so I could have restarted through the software the first time, but that time I couldn't. And let me just make sure that's off. Right, let's turn it off. That's probably why that enable was on. Proceed without humming. I'm not even using that. I think I might have to shut it off for a second. I don't think it. I gotta let the capacitor in the power supply completely go off, or it doesn't know that it's been reset. That's happened to me even with the other servos. When they get into an alarm state, you have to shut it down completely where there's no power, which these things take a second to drain, believe it or not. Even the small one is still on. And still on. Probably all the capacitors that they have in them, they store enough energy that they are on for a minute or two. I mean, not a minute, maybe up to a minute. All right. Why aren't I getting a light over here? Oh, it totally smashed my limit switch. Oh, it demolished my limit switch. Holy mackerel. Yeah, I got to get a new limit switch now. That's great. That thing smashed the hell out of it. Totally smashed my limit switch. That sucks. So now I got to get a new limit switch. But I have them, but I just have to install a new limit switch. But so anyways, be careful with them, because when they tell you how powerful they are, they're really that freaking powerful. They're crazy powerful. So I'm going to figure out what's going on here, and I'll bring you guys back when I know and I get it moving. and I get it moving. But you see, just, I mean, it moves so fast. They're so freaking powerful. I'll get you guys, I'll bring you guys back as soon as I get that moving, and I'll do another clip just so you can see it moving back and forth the way I was doing it last night. And then I'll bring you back again after that when all of them are done. Unless I get carried away, I'll show you when all of them are done. Either way, you'll see soon enough later. What's going on, guys? So it was when it whacked the side, when it went too far, it knocked the connect. I didn't have the connector pushed in all the way for the power, so it just knocked it loose. That's what it was. But it does go into alarm state when it reaches the limit, or when it gets feedback like that. But it did destroy my my limit switch for sure. I ordered a few new ones because I'm sure I'll probably demolish one or two more. But I'm going to show you. So I don't know if I can show you the screen at the same time, if this is wide enough, or my head's going to be in the way. Well, I'll show you the movement, and then I'll show you the screen, because it's pretty cool. The tuning software, you can see. Oh well, hello. I can do it right here. You can see the feedback from different categories. That's not my feedback. This is my feedback over here. That's another screen. That's a video of doing this. But I'm just doing like jerk movements, and these different colors are for velocity commanded, torque measured, different parameters, and it shows you the spikes on an oscilloscope for each parameter. It's pretty cool. It's a lot more detailed than the other software for the other servos. But I mean, I've got it on 1,000 RPM. I mean, I had it on 2,500 yesterday. I'll turn on 2,500. So just so you can see. I've never seen this machine shake like that at all, ever. Cutting anything. This one little NEMA 23 motor is shaking this whole 1,500 pound machine. It's unreal how much power these things have. When I'm doing like jerking movements, you'll see. You see that? It's unbelievable. This weighs 1,500 pounds with all the cement. It's just throwing that head around. Imagine the y-axis is going to have two of the same motor that's doing that. It's just tossing that thing like it's nothing. It's not even slowing it down at all. But you see the charts, you see the graphs? Yeah, it's a really powerful motor. All right, I'm going to get back to installing them. I've been messing around, testing them and everything, and configuring it. But I'm going to get back to installing it, so I'll bring you guys back for some more when I get them in. But yeah, that's what happened before, and it's all squared away now. I just got to finish wiring the other two, installing and wiring the other two, which, I mean, it's now that I know where all the pins are, they're all the same on all the motors. So once now that I know, what goes where, it should go relatively quick. So I'll be back. It'll be very quick for you. Lucky. See you in a few. What's up, guys? It's Chris. I'm back. So I got them squared away finally. So I am in cut control. You can see here. I'll make it the full screen. And this is my little handheld keyboard. It fucking throws that thing. This is as fast as it'll let me go in cut control. What is it bouncing on? I guess it's the drag chain. I got to extend this wire here for the fans on top. I put 2 fans on the top to cool the well, not to cool, to dry the inside after using the flood coolant. But I didn't obviously make it long enough. I'm going to extend that and wire and route it properly. But all the cables are back. All the 2 Y-axis motors. Let me bring you over here real quick. The 2 Y-axis motors were they're tight. They're pretty big for the amount of space that I had. I knew that they would fit. I measured and I knew that they would fit, and I even fit them with a fan on the back. So, and I have a little bit of space, but the USB plugs in right in the back. So it's very difficult to find the USB port. You can't see, so I'm like doing it by feel, and it's very difficult to get it in to the USB port and you know, hook it up. Luckily, I don't think I'll have to do it again because they're already all set. I did do a separate Y-axis, but I just changed a couple parameters. Like I had to reverse the Y-axis because it was going, you know, the opposite direction, but I got that squared away. But yeah, it's moving. I mean, the other ones were just as silent, but they just didn't have this kind of power. These things have a crazy amount of power. I mean, the thing is, cut control is only letting them use so much of it because it only goes 100 inches per minute. These can go so much faster. Like, and with a crazy amount of power, they can go so much faster. These motors have a ridiculous amount of power. So, I mean, honestly, the fans make more noise than these motors. It's pretty crazy. But I'm just taking the USB out, putting this rubber boot back on. I forgot to put it on this one. And so yeah, the fans I told you guys earlier, they're 40 by 40, 40, 10. So they're 40 millimeter fans, 10 millimeters deep. I could have used deeper ones. I have some deeper ones, but and that one I got to cut the cable and recrimp it, make it shorter. And then, so when I hooked up the X-axis, I didn't disconnect the 2 Y-axis. I don't know why I didn't think of that. And this is one of the other servos, the easy servos that was on the Y-axis. The other one, this one burnt out. I don't know why the other one didn't burn out, but this one burnt out for sure. It was 72 volts. You can't take the heat. Get the fuck out of the kitchen. So that one's getting out of the kitchen. But I'm happy. This thing is going good. Quiet, smooth. Really smooth, really quiet. It's, yeah, that's what I'm talking about. So now I'm gonna get back on the Fusion and start making some stuff to make some stuff. I gotta get back to my Z-axis lift. I'm gonna do that, and I'm gonna use my new water-cooled bandsaw, my new flood-cooled bandsaw that I have to look at in my history for that video and attach it in the description because I want you guys to see the guy that came up with this, because it's almost the same thing that he did as, you know, that I did. He did the same copper pipe like I did. That's where I got the idea. I just did I did a flange fitting. I mean, I do HVAC, so I have all the stuff to do this, and I know how to do it. So it's just a flange nut, and then a flange fitting, and a piece of copper, and you just make the flange in the end of the copper. You put the nut over, make the flange, and then I took just a Sawzall. I could have used my handheld bandsaw or even this one to make the cuts in it, but either way, it goes right over the blade. So it's going to be very effective. I haven't even cut anything with it. No, that's not true. I did to test it when I first finished, but I haven't cut anything substantial with it. Like, I haven't cut the rest of this big block of cast iron you see right here. That's for the Z-axis gantry, lift. But I'm going to finish that soon. Now that I got this done, that's the next thing on the list, is to get this Z-axis raised, the 2 1/4 inches that I'm raising it, and then this machine will just be machining, and I'm done, you know, messing around with it. That's the last of the stuff that I really wanted to do to this. I went through 3 sets of motors. I mean, seriously. So these motors are unbelievably powerful. They're everything. They're more than they're cracked up to be. I don't think people actually are descriptive enough when they say how powerful these are, because they are. I mean, dude, this whole enclosure was bouncing around. This thing weighs 1,500 pounds. It's unreal. These motors are crazy powerful. They're crazy powerful. It's for the size of them. It's insane. It really is. It's hard to believe that a NEMA 23 could have that much power, and I really don't believe that there's any others out there that have that much power. The manual to this thing is a freaking novel. I've spent more time reading than anything else the last two nights, doing this. Well, not more than, well, I don't know exactly how much time I spent reading, exactly how much time I spent assembling and testing, but I spent a substantial amount of time reading. It's over 200 pages. So yeah, I mean, there's a lot to it, and I didn't even get into the software section. I only went through the hardware and programming section, because that's all I needed to see. The software section, I mean, the software is pretty much. I don't know if you guys ever watch any of my other videos, and you know I program all my other stuff. So if you've done some programming, you've done it all. It's not exactly, but I've done servo motor programming on other servo motors. So it's essentially the same thing. Oh, sorry, this is all part of that too. Oh, yep, that's only 100 pages of it, or 98 pages of it. That's the whole thing. Jesus. All right, so that's done. I'm going to put the cover back on the electronics enclosure. It's the same way that I just showed it to you last. It has the 24-volt power supply that's feeding the enable, the manual enable that I added this emergency stop on the, hold on. This emergency stop, I think I showed you earlier, it's right on the front leg. That red button right there, that's what shuts off the enable. What if that's off, these motors don't work. So if you don't have an enable on, or if you're doing an MR1, these don't have an enable, you have to make an enable. So that was the easiest way to do it for right now. I'm gonna start looking into other control boards and other softwares and see if there's, because the software is a big deal. If you don't like the software, you gotta get a board that goes with software you like. And that's why I stuck with cut control this long. I don't like the limitations, but other than that, I do like the software. So, now the limitations are getting in the way. Now that these motors are so damn capable, I could probably be cutting with all this, and then the spindle I'm undecided on. I have the 24,000 RPM 2.2 kilowatt water cooled motor, but I really do like the AC servo, so I'm conflicted. I'm gonna hook that motor up at the very least. I'm gonna hook it up and test it with the variable frequency drive. I'm gonna hook it up and test with it. But I mean, 24,000 RPM sounds pretty enticing, and I would definitely need another software, another control board and CNC software. So I'm going to get the Z-axis lifted and take it from there. Take it one step at a time. I mean, I bought it because I was curious and I wanted to see if it was something I would actually think about doing, which I'm thinking about doing it. I'm not decided if I'm going to or not. Generally speaking, that means that I'm going to do it, but on this one, it's not necessarily what it means, because I like this AC servo. They have a crazy amount of torque, and 8,000 RPM with that much more torque compared to, I mean, then again, I'm not familiar with the motor. The other motor's pretty big. It's long. It's a cylindrical long motor, and it has the same collet, which I wish it had a little bit bigger collet, but it is what it is. I mean, you can get up to 1/2 inch on here, and I've managed to make a 3-inch facing bit that has a 1/2 inch drive. So, and I can change out my 2-inch. It's the same arbor from an MT3 for my lathe, or was it an R8 that I machined down? I don't remember. Either way, it's I have an R8 that can be switched from both for this, and then I have the 1/2 inch that can be switched from both. And it does the arbor does give a lot more mass than you want, because it's got like this one here. It has these two side pieces that keep them together, but that's like another whole inch of space taken up. That's where the Z-axis really gets in the way. I'm gonna just level out this table. That's where, yeah, the Z-axis really gets in the way like that. I have to wear that freaking mask over my face when I'm machining this. It's so what the hell? That's on 120 volt. No, that's not what it is. Oh, this is off. That's what it was. That's not what it was. What is it going on here? What is up with this one? What's up with my Z-axis? Something got unplugged. What is... Oh, that's great. Well, it's that. It's sparking right there. I don't know what I did there. This has been... I haven't had any problem with this. I don't know what's going on right now. Let's shut that off. This is probably... It's just one of these... heat shrink things got loose. I gotta put a better connector on that. I didn't have a female connector for one side of it. Yeah, I gotta do that. I didn't have a heat shrink connector. I mean a female connector for one side. So what I did is I used a board, like a pinned out female, and I just soldered wires to it. So I have to, I have a female and male of a different type of connector. That's what I'm going to have to do. Like this. These are the pins that would normally go into a board, and you see that heat shrink started coming back and heated up. And it looks like even the solder's coming loose from it. So that's why it's not working. But I'm just going to cut all those wires and crimp them with fittings that I have a female and a male for. Oh, I wanted to move the table. That's why I turned that on. But this thing has been great, and I love those handles from McMaster Carr. When I ordered the material, I ordered that too. But the X-axis motor and the motor mount, the 3D printed motor mount that I printed out of ABS in like a really high infill, and it's crazy strong. That was designed by somebody else on YouTube, and I still don't know his name, because he doesn't do videos. He just did one, like on his whole channel, his whole page, it was just that video and one other. So he doesn't really, you guys won't know who he is. But if you look it up, Precision Matthews PM30 X-axis power feed, you'll find it. Anyways, he deserves the credit, because it was a good design and it worked out great and it fits perfectly, and even the coupling that he made it fits perfect, and everything works great. But anyways, this is one more thing off the list. I'm finally done with the motion system. I'm not changing the motors again, for real this time. So I'm happy to have that part done and be able to focus on the Z-axis, because that is one thing that I really would like to get done, is to raise the gantry and have some more space to machine in. And yeah, there we go. That's it. I probably should have known that I would just go with the best in the end, and done that in the first place. And there's not really a best for the spindle motor, I mean, that I know of. You know, if it's something that's like that needs the rigidity, needs the quality, it really needs it, then you have to go with the best, because you're gonna end up buying 3 times if you don't, like I just did. You know, you just watched me. So and that wasn't because they all broke. It was because I just was indecisive and wanted to try everything, so I did. But the point is that what was the point? I have no idea what the point is. The point is, buy once, cry once. Just, you know, do it right. So anyways, that's that. I'm gonna call it a night for tonight. I'm not doing anything further on this tonight. Tomorrow I'm gonna start cutting those blocks down and finalizing the machining process and get that thing running, because I'm actually going to probably run something that's already designed tonight just to test it, because I want to see it cut. But you know what, I might just bring you back in a few minutes for another clip doing that, just to show you the thing machining with that. But one way or another I will show you before the end of all these videos with the MR1 upgrades, but if not tonight, then shortly. All right, have a good night, guys. Appreciate you guys as always, and can't wait to see this thing running. So I'll see you soon. Later.